Okay, I wanted to review 3 problems from the quiz that caused the most difficulty. First, a problem read that a cart was moving 8 meters in the first second, another 8 meters during the second second of travel, another 8 meters during the third second of travel. So if you look at that, you can ask, well, what's the acceleration of the cart? Well, if it moves 8 meters in 1 second, then another 8 meters in the second second, it looks like the velocity is constant. The velocity is 8 meters per second every second. 8 meters per second, 8 meters per second, 8 meters per second. So the velocity is not changing, it's constant. Therefore, by definition, the acceleration, which is defined as the change in velocity per unit time, would be 0, because there is no change in velocity. This problem doesn't require any math except to just understand the problem. The second problem was very similar. A car, that was problem 3.16. 3.17, a car moves at a constant velocity of 100 meters per second for 10 seconds. Find the acceleration. Once again, anytime you have a constant velocity, that means the change in velocity is 0. And if there's no change in velocity, then by definition, your change in velocity is 0 for a period of 10 seconds. That's still 0 meters per second squared. You have 0 acceleration, just like you did in the previous problem. These 2 conceptual problems caused a lot of difficulty. Problem 3.24 is a guess method problem. It says a ball rolls down an incline from rest. That means the initial velocity is 0. So we're going to use the guess method for this problem. It accelerates at 2 meters per second squared, so you know the acceleration rate. For 3 seconds, that's the time interval. How long is the incline? So how long, that's a length or a distance measurement. So the unknown is the distance, essentially, that the ball travels down this incline, and it's asking how long is the incline. So we know VI, A, and T, but we don't know D. There is an equation that'll help solve for that the distance traveled, or displacement, of the ball is equal to the initial velocity times time, plus 1/2 the acceleration rate times the time squared. And if you substitute your given information, you have an initial velocity of 0 times 3 seconds, plus 1/2 the acceleration rate, and the acceleration rate is 2, times the time squared. So you put a 3 here squared, and you square that time. So we have identified the 3 givens, the 1 unknown, the 1 equation, and now we just simply substitute the givens into the equation, and we solve. 0 times 3 is 0. That cancels out. 3 squared is 9. 1/2 times 2 is 1. So 1/2 times 2 times 3 squared is just simply 9. And your units will be meters. If you start with SI units, we start with meters per second squared for acceleration, a time of 3 seconds. When you substitute your values in here, the seconds of time squared will cancel the seconds squared in acceleration, and you get your meters. But once again, it's helpful to make sure you lay out that equation and substitute. For your problems on the quiz, if you scored below a 75%, I would expect you to write out your work to explain your problems. Explain, why the acceleration is 0 in these earlier problems. Explain why the answer is 9 meters by showing your work using the guess method. Share that work with me, and then I can raise your grade.